All right. As part of exercise that we're doing currently to do some revision in terms of chemistry or physics, so that before the examination we can see what we can write. So we continue with the series. Okay. So today we are going to see some questions. If you are new to this channel, don't forget to subscribe and also click on the notification bell icon. All right. Without wasting much of your time, let's get started. Looking at the first question that we have here, what is our first question? Now, the first question says hydrogen plus bromine gas will give you 2 hydrogen bromine. Now, the question says the reaction above is carried out at 25 degrees Celsius. The temperature that it was carried out, the temperature is how many? The temperature is 25 degrees Celsius. Then if delta H is how many? The delta H for the reaction is minus 72 kilojoule per mole. All right. And delta S, which is your entropy, delta S, known as your entropy, is equals minus 106 joule per mole per Kelvin. Joule per mole per Kelvin. Now, they say that the reaction will be what? Now, for us to know the reaction that can be spontaneous or non-spontaneous, these are the conditions that you need to know. For spontaneous reaction, please, I need you to take note of one thing. I need you to take note of this that I'm saying now. For a spontaneous reaction, take note of this reaction, you need to know the following. Before I explain about a spontaneous reaction, let me take your mind a little bit back about what you call the Gibbs free energy. Gibbs free energy is given as delta G is equals delta H minus T delta S. Now, whereby G is known as your Gibbs free energy, G is known as your Gibbs, Gibb, Gibbs free energy is given as Gibbs free energy, whereas your delta H is, now, that one is called your enthalpy change. It is known as your enthalpy or your heat change, enthalpy change because of the change. Then the T is known as your temperature. This your T is known as your temperature. That is called your temperature. Then your delta S or your S is known as your what? Now entropy. And entropy just simply means the degree of randomness. So that your S simply means your entropy. Entropy. And entropy just simply means the degree of what? Disorderliness of a particle. That's what we mean by entropy. So it means that gas has more entropy than liquid, than solid, because in terms of solids are close. The particles of solids are closely packed. They are not loosely packed. They are not loose like that of your gas. Gas are loose. So that is one thing that you need to know. So which means that gas has higher entropy than that of the liquid, than that of what? The gas. So than that of the solid, sorry. So now for us to know what is called whether the reaction is going to be spontaneous or the reaction is not going to be spontaneous, now you need to take note of one thing. For spontaneous reaction, you need to take note of, please take note of this. Bring out your material, writing material, and also write out this now. So for a spontaneous reaction, RxN means reaction, please. That's what I mean. For a spontaneous reaction, the following conditions must be met, or the following conditions has to be met. Before I talk about the conditions that have to be met now, first of all, your delta G, delta G has to be what? Has to be negative. Your delta G has to be what? Has to be negative. That your Gibbs free energy has to be negative. So which means that, when I say delta G is less than zero simply means they are negative. It also means that from what I have here now, since delta G is less than 0, I can also say that delta H minus T delta S will also be what? Will be less than 0, because I once told you that delta G, which is this value, which is delta H minus T delta S, well, I've already said that this delta G must be less than 0. So what I did was that I replaced this my delta G that is here, this my delta G, which is the same thing as delta H minus T delta S. I have to replace it here, and I now have to put my delta 0. So now this means that this is less than 0, and less than 0 simply means that it is negative. So for your delta G to be, for the reaction to be spontaneous, your delta G must be what? Must be negative, which is what I have here. It must be negative. And the conditions that will make your delta G to be negative are conditions that will make your delta G. Remember, I said that for a reaction to be spontaneous, your delta G must be what? Must be 0. And the conditions that will make delta G to be negative are 1. Let's look at the conditions. First of all, the first reaction is going to be what? When we have our delta H, when our delta H is negative. Now, when you say delta H is negative, it simply means that the reaction is what? Exothermic reaction. So when you have your reaction to be what? Negative, which is exothermic reaction, then again, what again? Then delta S is also negative. So when delta H is negative and delta S is negative, now what happened now? When delta H is negative and delta S is negative, now what will happen now? The delta G that we're going to have is going to be what? Is going to be negative. But this condition has one thing. There's one condition that you need to understand. And for this condition, you need to understand one thing. When delta G is negative and delta S is negative, ensure that this your delta H here is greater than this your delta S. So which means the negativity of this your delta H must be greater than the negativity of this your delta S. So if you look at this question, let's take a look at this question before I give you other conditions. Look at this question. You see, look at my delta H here. Look at my delta H. It is minus 72 kilojoule. And look at my delta S. My delta S, the value of my delta S here is minus 106 joule per mole per Kelvin. And I know that that minus 72 is greater than what? Minus 106. So like I say that, but for this condition to be possible, what did I say now? I said that that your delta S, or let me say T delta S, let's call it T delta S, because this delta S always comes with your temperature. So when you combine your T delta S, your T delta S, which is must be at a lower temperature. Sorry, your T delta S must be your T delta S must be less than what? That your delta H. So that is what I'm saying. So what I'm trying to say is this: now when you combine, though we still saw we are going to see, when you combine this, which is our delta S, with the temperature, where is our temperature? With our temperature here, when we combine both of them now, the value we're going to get is going to be supposed to be less than this. And at that point, you will now say that my delta G will be what? My delta G will be what? My delta G will be what? Will be negative. I can get my delta G to be negative. And remember that if my delta G is negative, automatically the reaction is going to be what? Spontaneous. Then another condition is what now? When I have when delta H, which is what we have here, when it's delta H is negative, which is exothermic reaction, delta H is negative, and our entropy is also what? Is positive. Delta S is positive. So at this point now, our delta G will be what? Will be negative. At this point, our delta G will be what? Will be negative. So at this point, our delta G will be negative. So I'm only trying to show you the conditions. Then another condition is, another one that you need to take note of is, you need to bear this in mind. Then because the third one, for this first two, it has to do with exothermic reaction. Now the third one I'm going to talk about is going to be endothermic reaction. So for your delta H, for endothermic reaction, it's always positive. Remember that it's always positive. So when your delta H is positive, it will be spontaneous if there is a large change, delta S. So if there is a large change, that is when you have it for this to be spontaneous and delta H is positive, what you're going to have is this now. Your T delta S must be greater than what? Than your delta H. So this is when we are going to have what you call a spontaneous reaction, which is something that I said initially at the beginning of this class, which is, when you reverse this now, if you take this to this side now, it's going to be what now? It's going to be 0 is greater than delta H minus T delta S. If you reverse this, it's going to be what now? If you reverse this now, what is it going to be now? It's going to be, let me put this in properly here. I forgot. So let me put this properly here. So I'm trying to say that if you reverse this, it's going to be, when I just say that your T delta S is greater than your delta H. So if you reverse this now, if you take this subject of the formula, take this to this side, it's going to be what now? 0 is greater than what? Delta H minus T delta S. If you reverse this, 0 is greater than is the same thing as saying delta H minus T delta S is less than 0. This is one of the comment that I say that the condition that will make your delta G to be what? To be negative. So that is it. All right, now since I've explained for that of a spontaneous reaction, for non-spontaneous, for a non-spontaneous reaction, what exactly are we going to have? Please listen to the non-spontaneous reaction. A reaction will not be spontaneous at all temperature if its endothermic, that is delta H is positive, and entropy change, which is delta S, is negative. So whenever delta H is positive, so non-spontaneous reaction, for a non-spontaneous reaction, let me clean up this. For a non-spontaneous reaction, what will happen for non-spontaneous? So for non-spontaneous spontaneous reaction, you can complete this. You know what I meant by this. For a non-spontaneous reaction, NEOS reaction, what exactly will happen now? So what will happen for a non-spontaneous reaction is, now a reaction is said to be non-spontaneous at all temperature if the endothermic reaction is that the delta H is going to be positive, and the entropy is what? Negative, and the entropy is what? Negative. So when this condition is met, when we have a condition like this, automatically what we're going to have is what we call a non-spontaneous reaction. Okay, so the reason why I'm explaining is this now. I do say it normal, basically, that your examiner, this exam you're getting ready for, they are only trying to see if you understood, if you have an in-depth knowledge of that subject matter or the subject. That is only way you can answer their question. So you can't cram anything there. So let's look at the question. Let's answer this question. Let me clean up and answer this question. So coming to this question that was given here, so how do we answer this question that was given here? Let's quickly look at the question and see how the answer is going to look like. Now, I was given my temperature. I was given temperature. Yes, I was given temperature. What else now? I was given my delta H. So what I'm going to do is, let me start with the temperature. My temperature is going to be what now? 25 plus 273. 25 plus 273 Kelvin, to convert it to Kelvin. So this I'm converting it to Kelvin to give you 298 Kelvin. So I've gotten it in Kelvin. The next thing I'm going to do is, let me apply this formula and see what is going to happen here. I have it as delta G is equals what now? Equals, remember the formula, delta H minus T delta S. So I'm going to have it as delta G is equals to, what is my delta H? My delta H is what? My delta H is minus, minus 72. I'll write minus 72 here, minus brackets. What is my T? What is my T? My T is this value, which is 298. Then times, what is my delta S? My delta S is minus 106. I'll close my brackets. So when I multiply these two, now what am I going to have? Now I will say delta G is equals, remember that when these two multiply each other, they will give you minus, and minus times this minus outside will automatically give you plus. So for that reason, when I multiply everything out, what am I going to have? Let me bring up my calculator so that you'll be sure of what I'm doing, so that you'll not be confused. I'm going to say 298 times 106. 298 times 106 will automatically give me what you call 315. So I will say minus 72 minus brackets. Bracket what? Let's clean up this place so that we can see a space and write what you want to write. So I'm going to say minus 72 minus, we have it as minus what? minus 31588. So 31588, sorry, let me put this very well. So we have a 31588. So that is exactly what I'm going to have. So that is it. So what I'm going to have here is, I'll just quickly say, what is my delta G? My delta G is equals minus 72, minus will give me plus 31588. So what I'm going to have is, when I say minus 72, oh, I am making a particular mistake. What mistake am I making in this my calculation? The calculation says, the value says for delta H, it says minus 72 kilojoules. So this says what you call minus 72 kilojoules. Let me use another pen. I'm saying minus 72 kilojoules. And I'm not using 72 kilojoules here. So let me correct this. So let's quickly correct this error that we're having here now. So let's clean up this. Let's clean up this. Let's start from the beginning and solve this. So what we're going to have here is, we just say delta H is equals, what is my delta H? My delta H is what? Minus 72. Because of this kilo that we have at the back, is going to be 0, 0, 0, add 3 zeros. So minus bracket, what is my T? T is 298 times, what is my delta S? My delta S is minus 106. So when I solve that, it's going to be delta H is equals minus 72123 minus brackets minus 31588. Okay, so this is going to give you minus 72123 minus will give me plus 31588. So what we're going to have is, when you subtract both of them, minus 7200 plus 31588 will give me what now? We'll have it as answer minus 7200 is going to give me. So the final answer I'm going to have here is minus, yes, it's going to give me minus, I'm going to have it as minus 412. So that is joule per mole. That is what I'm going to have. So if I convert it to kilojoules, it's going to be what now? I'm going to have it as minus 40.4 kilojoule per mole. That's what I'm going to have. So if you look at this now, what exactly are we having here now? So why am I even writing? Sorry, why am I even writing delta H? Yes, did I write delta H? See, please correct this. This is not delta H. This space is not delta H. Please correct this. So what am I supposed to write here? Please, what I'm supposed to write here is delta G, because according to the formula, I have delta G is equal to delta H this. So I'm going to have delta G here. I'm going to have delta G. So the final answer that we have is delta G. And you can see that our delta G is what? Negative. Remember, I told you that if our delta G is negative, what is it going to be now? Will our reaction be spontaneous or not? The reaction is going to be what? Spontaneous. Remember when I say something like that? So let's look at our options and see the correct answers that we have. So the first answer that we have here is that the first one says that the reaction will proceed spontaneously at lower temperature. Well, at lower temperature, well, let's continue. Not proceed. No, the option B is not answer at all, because we've gotten the answer is negative. So anything not spontaneous will not be included. So let's look at this one. They say proceed in the reverse. That one, this option D is not included, because if you look at it, they said proceed in the, there's nothing like spontaneous reaction here. So what I'm going to do is, first of all, let me start with those of them that has the word spontaneous. So select the ones that has the word spontaneous and remove the ones that doesn't have the word spontaneous, so that I will know the correct one that is the correct answer. So what I did is I removed those of them that doesn't have spontaneous in it. The first one says non-spontaneous. The second one proceed. So it has nothing like spontaneous in it. So I'm left with option A and option C. So the correct answer is going to be, well, for option A, they say at lower temperature. They were not specific. Then for option option C, they said proceed spontaneously at a given temperature. We have a given temperature, and what is the temperature? that it will proceed? It will proceed at minus 40.4. So the correct option is what? Option D is the correct answer. So that is it. So let's quickly go over to the next one. Let's go over to the next question. I'll be a bit fast in some of them, so we know how far or where we're going to cover before we shorten this video, because this video cannot be too lengthy because of the explanations. So let's look at the second question. The second question reads that you are given this reaction. This reaction is, we have this reaction here. We have this reaction, sodium carbonate, sodium triiosocarbonate 4. We are given hydrogen chloride acid, HCl, as the second one. Then you're also giving what you call that to give you salt, water, and carbon dioxide. And automatically, I've known that this kind of reaction is a neutralization reaction. And even if you read the question, look at it, they say neutralizes it. So this is a neutralization reaction. And since it's a neutralization reaction, now you think about the formula for neutralization. Basically, the formula is always CAVA all over what? CBVB is equal to NA over what? NEB. Please take note of one thing. This formula is, there's another formula that is called C1V1 is equal to C2V2. This formula is called dilution formula. This second formula that I wrote is called your dilution formula. You only use it when you hear the word diluted, it's diluted. So that is when you use the second formula. So the second formula is used when you hear the word dilute, that this diluted. So that's when you use this second formula. But for the first formula that I have here now, it has to do with what you call acid base. It has to do with what you call neutralization. So now let's look at this. If you look at my question now, what do I have here now? They asked me to calculate the number of moles of getting of what? Sodium carbonate, number of moles of our base, okay, of sodium carbonate, number of moles of sodium carbonate, that's what we're looking for. And you are given the volume of sodium carbonate. Let's call volume of sodium carbonate. You are given the volume as how many now? As 25 cm cube. Then you are also given, they say that, okay, are there in 25 cm cube solution which required 10 cm cube of 0.05 mole per dm cube hydrochloric acid. So this 10 cm cube that you are seeing here is known as your what? Your volume of your acid. And our acid is what? HCl. So volume of our HCl is equals 10 cm cube, is equals 10 cm cube. Then the next thing that I have here is I'm going to have it as, okay, I have volume of then I've gotten my volume. Then the next thing I have here is I have concentration of our acid, concentration of our HCl. How did I know that this is concentration? They say that acid, okay, the 10 cm cube of 0.05 mole per dm cube. Mole per dm cube is called molar concentration. So our concentration in mole per dm cube. So that your molar concentration, we always represent it with letter C. So our molar concentration of our acid is given as your what? As 0.05 mole per dm cube. So how do I get my number of mole? Let me show you how to get my number of mole. Before then, what is the ratio for our sodium carbonate? Our sodium carbonate is given as what? Also, okay, let me put it this way. Let me rewrite this parameter so that we can make it easy, so that for easy fixing of parameter, let's fix this let's do this in this way. Let's change it this way so that we won't waste time. Let's call this one, normally this one is called your base and this one is going to be called your acid. So let's rewrite the parameters again. So if I do rewrite the parameter again, this one, how many moles? We are looking for number of moles of sodium carbonate, number of moles for sodium carbonate. That's what we're looking for. And are there a 25 cm cube in a 25 cm cube, so which is volume of our base. You know, this 25 cm cube is for that sodium carbonate. So volume of our base is 25 cm cube. Then require 10 cm cube of 0.05 mole per dm cube hydrochloric acid. So that volume that we have here is called the volume of acid, which is equals 10 cm cube. Then our Ca, which is this Ca, this is your Ca because it involves hydrochloric acid, and I told you hydrochloric acid is your A. So our Ca is equals 0.05 mole per dm cube. You know, I'm using this so that it can be easy for us. Now, what is my Na? My Na is this. My Na is this. The number in front of our acid. We have it as what? As 2. Then what is my Nb? The number in front of our base. The number in front of our base is what? 1. If you look at this formula that I have here, from the formula that I have already, I have the following. What do I have now? I have my Ca, I have Ca, I have Ca, I have Va, I have Va, I have Na, I have Nb, then I have Vb, then I don't have Cp. So automatically from this, we're looking for our Cp. So let's quickly solve that without wasting much of our time. So what I'm going to do is, I'll just say my Cb, since I don't have Cb in this equation, I'll just say CaVa times Nb all over, that is cross multiply. That's what I did, cross multiply. This will multiply this, then this one will now multiply. Vb will now multiply your Na. I'll just say Vb times Na. So what I'm going to say is, I'll say Cb is equal to, what is my Ca? 0.05 times, what is my Va? Times 10 times, what is my Nb? 1 all over, what is my Vb? My Vb is 25 times 2. So what I'm going to have is, I'm going to have it as this. So this is going to be 0.05 times 10 times 1 is going to give me 0.5. 0.5 divided by what? Divided by 50. So this is equal to 0.01 mole per dm cube. Now this mole per dm cube is my Cb. I've gotten my Cb now. Automatically I've gotten my Cb. Okay, let's divide 0.5 divided by, okay, divided by 50. Let me be sure. 0.01. Then I've gotten my Cb. What next am I going to do? Since I've gotten my Cb now, the next thing I'm going to do is, I'll get the number of moles as asked in the question. And for me to get the number of moles, I'll say number of moles is equal to C times V. So I will just say the number of moles, which is equal to my Cb times the volume of your base. So what is my Cb? 0.01 times, what is my Vb? My Vb is 25. Since it's in cm cube, I'll convert it to dm cube by saying divided by 1000. So when I multiply everything, what do I have now? I'm going to have it 0.01 times what? Times 25 divided by 1000 is going to give me what? 2.5. So the answer is going to be 2.5 times 10 raised to the power what? Times 10 to the power minus 4 moles. So the correct option, the correct answer is this. But if you look at the question, there is no option like that in the question. They basically left the answer. Some persons might be thinking that the answer is going to be option A, but the reason why I'm going to disagree for option A is this. Now, when we got our Cp, as 0.01 mole per dm cube. Per dm cube simply means per 1000 cm cube, but they want it in 25 cm cube, not in 1000 cm cube. That is why we have to divide it to get it in 25 cm cube. Please, I hope you are getting what I'm saying. When we see, let me say something. The reason why I say that there is no option, there is no answer here. The answers, there is none of the options here. None of them has the answer. Is this now? If you go by what we have here now, let's say this is your Cb now. You got your Cb as 0.01 mole per dm cube. 0.01 mole per dm cube means 0.01 mole per 1000 cm cube. But they were asking you to get the number of moles of sodium carbonate that are there in 25 cm cube, not the 1000 cm cube. So for us to get it is in 25 cm cube, that is why we say the 0.01 times that volume in that times volume, that volume that we're given, that is the 25 cm cube, which is 0.25 dm cube, and we're getting this answer as the correct option. But if you look at it, it is not there in the option. So the correct answer is this, even though it's not in the option. So I believe you must have understood why I have to leave it this way. Okay, let's go over to the next question. A quick one. We are not going to be wasting much time. So if you look at the third question, says that the iron that can be used as an oxidizing agent is what? Now, what you're going to do is, I read any question, you pause the video, and see if you can answer it. Look at question number 3. So what's the answer to this question? Okay. If you look at this now, the only thing I must tell you is this now. Oxidizing agent, for oxidizing agent OA, oxidizing agents will be what? They are always reduced. And out of all these things that I have here, out of all these ion, which of them can be reduced? If you look at the gold ion, gold ion, it can be reduced to what? The only ion that can be reduced to another ion is what? Ion, this ion 3. Ion 3 ion can be what? Can be reduced. That is, ion 3 ion can gain electron. If it gains electron, it can be reduced to what you call ion 2 ion. So you see that this ion 3 ion is the only ion that can gain electron and become reduced to a lower form of its ion. So and this process is called, this process will now make this ion 3 to become an oxidizing agent. Remember that an oxidizing agent will be what? Will be reduced. So quick one. Let's go over to the next question. Question number 4. Question number 4 says what now? Zinc and carbon rods. Zinc and carbon rods, where do we find it? Zinc and carbon rods are used as an anode and cathode, respectively, in where? Where do we use zinc and carbon rod? If you may recall, it can only be used in what we call the Leclanche cell. Leclanche cell. That is when we use it now, whereby the carbon rod forms the positive electrode, whereas the zinc forms the what we call what now? The negative what? Electrode. Still also remember that Leclanche also undergo what you call polarization. So we use what you call manganese 4 oxide as the depolarizer to make sure that it takes away those hydrogen that is being liberated. Okay, so the correct answer is going to be what? Leclanche cell, so which is option C. Quick one. The next question says triosonate 5 is not used for preparing hydrogen gas from metals because triosonate 5 is the only strong oxidizing substance that we have. So the correct answer is what? It is a strong, it is what? Strongly what? Oxidizing. So it's strongly oxidizing. So that is it. So question number 6, pause this video and read to see if you can answer the question number 6. Number 6 says that if the heat of combustion of hydrogen is this, heat of combustion of hydrogen means that we have hydrogen plus oxygen. So when you have hydrogen plus oxygen, it will give you what you call H2O. So when you balance this way, we have this. But you know, when you talk about heat of combustion, it's going to be under 1 mole. It's going to be the 1 mole. So 1 mole of, because whenever you talk about heat of combustion, heat of formation, it's not going to be the 2 mole of it. It's going to be 1 mole of that substance that will be used. So for that reason, 1 mole of this is going to be, if you get 1 mole of this, 1 mole of this is going to be half mole of this. 1 mole of this, 1 mole of this is going to be half mole of this. Half mole of this will give you that. So we have this way. So for that reason, 1 mole of hydrogen, 1 mole of hydrogen will give you hydrogen. Sorry, this is hydrogen. Sorry, this is hydrogen. Sorry. 1 mole of hydrogen. Oh, my equation was even correct. I was the one making a mistake. Sorry. I was the one. Please let me write the equation. I was the one making a mistake. I have it as hydrogen plus oxygen to give me what you call H2O. So 1 mole of oxygen, because I want this thing to be 1 mole, this is going to be half, because half of this will give me ordinary oxygen. So this is for 1 mole. Remember I told you for heat of reaction, heat of formation, heat of any heat, we always do the calculation using what you call the 1 mole. So 1 mole of hydrogen will give me what you call, will give me 1 mole of what? 1 mole of water. Now they say that the heat of combustion of hydrogen, that of a hydrogen, the heat of hydrogen is how many now? Minus 285.8 kilojoules. Okay, what is the heat of formation? So what is the heat of this water? The heat of this water is X. So you cross multiply, it's going to be what? X is going to be what? Cross multiply is going to be minus 285.8 kilojoule. Why? Because if you multiply this with this, it's going to give you the same answer. So the correct option here is option A. All right, quick one. Now the next question says, question number 7 says that, can you solve this question number 7? If you can, pause this video and solve it. Before then, if you can't, let's quickly look at it. For question number 7, it has that In the electrolysis of copper 2 sulfate aqueous, you see what they wrote aqueous, so which means that it is copper 2 sulfate solution. And copper 2 sulfate solution contains two things. What does it contain now? It contains what we call copper 2 sulfate, and it also contains water. And in electrolysis, there is going to be what we call decomposition. So if this thing decomposes, it's going to be copper 2 ion and sulfate ion. Then this is going to give me what? Hydrogen ion and hydroxide ion. All right. These two will go to the place. We'll go to where? These two are the positive ion. They'll go to the negative electrode called cathode. So cathode first. And these two will go to the where? These two will go to the what they call the anode. Okay. So the question says using in the electrolysis, it says using platinum electrodes, the reaction at the anode. So let's go back to the anode. Now coming to this anode, now which of them will discharge? Discharge meaning that which of them will lose electron or gain electron. So sulfate ion or hydroxide ion. The one that will discharge is what we call the hydroxide ion, because hydroxide ion is lower in the series than sulfate ion. Sulfate ion is higher in the series. So we are going to have it as hydroxide ion will discharge. And remember, I do tell you that this, if this loses one electron, it's going to form one electron. It's going to form, let's put this in properly. If this loses one electron, this is water here. If this loses, it's going to form hydroxide, which is useless. We don't need it. We'll have it as this again loses one electron. It forms another hydroxide, which is kind of useless. It's not useful. Like there's no component or compound or element like that. So when you combine both of them, it's going to give you H2O plus O. H2O, 2 hydrogen, and one oxygen. This is oxygen here, but oxygen is not a monoatomic, it's a diatomic. Because oxygen is diatomic, now you repeat this process again, so which is 2 hydroxy ion minus E minus to give you what is equal to give me H2O plus O. So when you combine everything together, it's going to be 1 2 3 4. It's going to be 4OH minus what again now? 1 2, this is going to be 2, sorry, 1 2 3 4, 4 electron to give me what? 1 2 to give me 2H2O. This plus this will give me what now? O2. So the correct option is what? Option D. So you see that now. Okay, quick one. Let's go back to the next question. The next question says, I hope you are learning from this that we are doing here. I hope you are learning a lot from it. I hope you are happy. Don't forget to like and share this video as well. All right, so let's go back to the question. The next question says, which of the following is the oxidation number of sulfur equal to -2? Well, if you ask me, I automatically know that the answer is going to be option A. But let's check, let's confirm to see if the one that will have -2. Let's check. Now, the way I'm going to save it is I will say H2S. Because I'm seeing no charge here, I'll say all equal to what? All equal to 0. So, and what is the oxidation number of hydrogen? Hydrogen is under group 1. And remember that group 1 element has oxidation number of what? Oxidation number of what? Tell me. All right, okay. It has oxidation number of +1. Group 2 has oxidation number of what? +2. Group 3 has what? +3. Group 4 has what? +4 or -4. So depending. Group 5 has what? -3. Group 6 has what? -2. And group 7 has what? -1. So it depends on the group where it belongs to. So for this hydrogen, which belongs to group 1, I'll just say 2 hydrogen. Because of these two here, I'll say 2 hydrogen plus sulfur is equal to 0. I'll say 2 brackets 1, because hydrogen is under group 1. I'll say 2 brackets 1 plus sulfur is equal to 0. So this is going to give me 2 plus S is equal to 0. S is equal to what? Take this to the next side. It's going to be what now? 0 minus 2. So which is equals to -2. So the correct option is what? Option A. Okay, now let's move over to the next question. The next question says 5SO2 plus 2KMNO4 plus 2H2O, 2 molecules of water, to give you 2 sulfate, to give you potassium sulfate plus manganese sulfate plus hydrogen sulfate. So now they say that this reaction above, and the reaction above, the products give A, what would the products give? You don't need to guess. You know, I see the way this examiners normally ask question now. So now you look at the options. The option says colorless solution, colorless solution. Another one says purple precipitates, purple solution. Another one says what now? Colorless precipitates. Now the correct option is going to be one thing. First of all, look at this now. You have sulfate, and you have sulfate. And according to the rule of solubility, sulfate does what now? All sulfate, all salt that has a sulfate are what? They are soluble. All sulfate ions are soluble in water, except that of calcium, which is slightly soluble in water, and so on. So because of that now, since they are soluble in water now, automatically, what happens now? Everything becomes what? The solution is going to be what? Colorless. The solution is going to be what? Automatically what? Colorless. So that is it. All right, now let's go back to the next question. The next question says, the solution that will conduct the highest amount of electricity, the solution that will conduct the highest conduct the highest amount of electricity is. So what solution will conduct the highest amount of electricity? The only one that will do that is if you are to know the one that will conduct the highest amount of electricity, do it this way. First of all, just start with what you call the non-electrolytes. Look for non-electrolytes. If there is non-electrolytes, the next thing you are going to look for is what you call the weak electrolytes. Look for weak electrolytes. If there is weak electrolytes, after that you now look for strong electrolytes. But when you talk about strong electrolytes, you now talk about the strong electrolytes. But when you talk about the strong electrolyte, now you must consider one thing. Under strong electrolyte, you have to consider the concentration. The one with lesser concentration, comes first before the one with the highest concentration, which is the one that comes last. So that is what we have. Now you might be wondering which of them will give you strong electrolytes. Strong electrolytes in my previous video, which I've already uploaded here. If you have not watched it, please go and watch my electrolysis. You see where I mentioned the strong electrolyte that we have. But the strong electrolyte that we have, basically what you call the strong acid, they are gotten from what you call the strong acids, which are only three in number: HCl, HNl3, HNO3. We have HCl, we have a HCl, we have HNO3, and we have a H2SO4. Okay, then another one is what you call your strong base. So your strong base, which is what you call sodium hydroxide and potassium hydroxide. So these two. Then the last of it all is what you call soluble salts. Ionic salt is the ionic salts that will give you that. Another one is what you call the ionic salts. So these ones will give you what you call strong electrolytes. The weak electrolytes are, anything that I didn't call here under the weak electrolytes. So which means that ethanoic acid, H2CO3, HSO3, all of them are known as what you call the weak electrolytes. So let's look at this option. Let me not waste much of your time here. So what am I going to do is, first of all, let's talk about, do we have non-electrolytes? Let's look. We don't have non-electrolytes here. Do we have weak electrolytes now? Yes, we have weak electrolytes. And our weak electrolytes are ethanoic acid, so we'll remove them. So we're now left with two options. And the two options that we're left with are the strong acid, hydrochloric acid and hydrochloric acid. And I told you that you must select, if you want to know that the one that will conduct highest, the one that has the highest concentration will conduct. So which of them has the highest concentration? Option C. So the correct option is what? Option C. I hope you are learning a lot from this video. All right, let's proceed to the next question. So the next question says, question number 11 says, what is the molar mass? We are looking for the molar mass. This question is very simple. Molar mass, okay, we're looking for molar mass if they have that our N is equal to 0.4 mole, and the mass is equal to 25.0 gram. So how do I solve it now? Well, pick one. We don't need to waste time. This is not a difficult question. Remember the formula that N is equal to mass over what? Molar mass. So your molar mass, will be equal to what? Mass over what? Your N. So which is equal to, mass is 25 divided by N is what? 0.4 So when you divide both of them, it's going to be, let's check your calculator, 25 divided by 0.4 will give me what now? 62.5 gram. So the answer is going to be what? 62.5 gram. And let's look at 62.5 gram is what? Option C as the correct option. Okay, so let's look at question number 12. Question number 12, quick one. So for question number 12, what do we have for question number 12? For question number 12, what do we have here? The question number 12 says the order in which a mixture of sand, we have sand which you know that is insoluble in water, ammonium chloride which you know can sublime, and sodium chloride which is soluble in water can be separated is, so the order in which a mixture of sand, ammonium chloride and sodium chloride can be separated is, what method can we use to separate it? It's very simple. The answer to this question is going to be what? Let's look at it. First of all, I will advise you, because we have the one that is, we have insoluble substance here, we have insoluble substance there, we have insoluble substance. Let me show you how I'm going to do it now. Insoluble substance, and the insoluble substance that we have here is what? Sand. Then we also have soluble substance, and the only soluble substance that we have here is sodium chloride, which is our salt, sodium chloride. Then we also have substance that can decompose on heating, substance that can decompose. We have substance that can decompose on heating, and that substance is ammonium chloride. So ammonium chloride. So if I am to separate these three things, what am I going to do? If I add water to this, automatically it's possible that my ammonium chloride will dissolve inside that water. And if because ammonium chloride is soluble in water, if I start with dissolution, if I dissolve my ammonium chloride inside this water, it will now dissolve with this sodium chloride. So if I filter out the solution, sand will be remaining. So how do I get ammonium chloride? See, it's going to be difficult. So the best thing I'm going to do is, I'll start with decomposition. I'll start with what you call sublimation, because ammonium chloride can decompose on heating. That is, can change from solid to gas on heating. So the first thing I'm going to do is, I'll start with sublimation to remove, instead of meters, to remove what? To remove this. Then after that, after I've removed that, now what else am I going to talk about now? I'm going to talk about what we call this solubility. So I'm not talking about dissolution. Next thing is going to be dissolution. That's next thing. Then after that, before I'll not talk about, I've dissolved it now, I will not filter. Then the last stage is going to be what now? Filtration. I will not filter to remove that sand and dry my sand. So these are the steps that I'm going to take. And the correct option is what? Option A. So that is it. Okay, so now let's go over to the next question. The next question says, the volume of 2.5 moles of oxygen at STP. The volume of 2.5 moles of oxygen. Whenever you see all these calculations in chemistry, they are very, very simple. You don't need to waste your time. Can you still recall the formula? Can you still recall this formula that N is equals, apart from mass over molar mass, can you also remember that it is also equal to molar volume over molar volume? So if you can remember this, it's also part of the formula. So I am going to use one thing. They gave me N in moles. This is my N. This is already in moles. So I'll quickly say N is equal to V over what? MV. So whereby my N is equals 2.5 moles. My N is equal to 2.5 moles. Then I'm looking for V. My V is unknown. And my molar volume normally is always a constant. Look at the value, which is equal to 22.4 dm cube. So what am I going to do now? I'm going to solve. I'm looking for volume. I'll just say that my volume is equal to N times molar volume. So which is equal to, what is my N? 2.5 times, what is my molar volume? 2.4 dm cube. And this will automatically give me what? Let's check the calculator. 2.5 times 22.4 is going to give me what now? 56 dm cube. No, I'm using this formula method because it's quite easier than first principle method. So the correct answer is what you call 56 dm cube, which is option C. All right, now going over to the next one. The next question says, what does the next question says? I told you, you can keep pausing this video and looking at the question to see if you can solve it. The next question says nuclear fission involves the splitting of heavy element into nuclei of. Okay, what does it say now? Okay, let me just say it now. Nuclear fission involves the splitting of heavy element into two nuclei of nearly equal masses. Remember the key word here is what? Nearly equal masses with release of what? Energy and what? Radiation. So the correct option here is what you call what now? Option B. So option B, which is what it says, nearly equal masses with release of energy and what? And radiation. So that is the correct option for that. All right, so the next question says, you are given this equation. Let's see this equation properly. The equation says 2C2H2 plus 5O2 will give you, to give you what? 4CO2 plus 2 moles of water. So our ethane combining with oxygen to give you 4 moles of carbon dioxide to give you 2 moles of water vapor. So in this reaction, what happened now? They said in the reaction above, the mass, we are looking for mass. Please pay attention to see where I'm going to solve it. The mass of carbon dioxide, okay, they measured carbon dioxide. We are looking for what? Mass, and they measured what? Carbon dioxide produced on burning 78 grams of ethane. They also mentioned ethane. So I don't need everything in this equation. The only two things that I need in this equation is what? Ethane and what? Carbon dioxide. That's all I need. And we're looking for mass of what? What are we looking for? We're looking for mass of carbon dioxide, mass of carbon dioxide. That is what we are looking for. So what am I going to do? I'll just say that 2 moles of ethane, that is from this equation, you can see that 2 moles of ethane, that is 2 moles of C2H2, 2 moles of ethane will give you what? What will it give you? Will give you 4 moles of carbon dioxide. Okay, now if you look at it now, the ethane that was given to you, this ethane, the value of ethane that was given to you, the value of ethane that was given to you in gram. That is 78 gram. So because it was given to you in gram, now you need to convert this ethane from this equation in gram, and that conversion involves what you call the relative molecular mass. So what I'm going to do is I'm going to convert this into gram. Therefore, carbon dioxide, they say we should get the mass in carbon dioxide, so I need to convert this one as well in gram. So what I'm going to do is I'll just say 2 bracket. This is going to be what? 2C, because of C2 is going to be 2C plus 2H. So to give me what? What is it going to give me? 4. Okay, 4. Let's put bracket, C plus 4, sorry, plus 2O. Sorry, plus 2O plus 2O. So let's look at how it's going to be. This is going to be 2 brackets, 2 times C. My C is 12. They give me the value of my C as 12. I'll say 12 plus 2 times, my hydrogen is 1. You're supposed to have known that. So it's equal to 4 bracket 12 plus, this is 2 times, this is O. O is 16. I will say 16. So this is going to give you what? 2 brackets. 2 times 2 will give me what now? 24. Sorry, 2 times 12. 2 times 12 will give me 24. 24 plus 2 will give me what you call 26. So I'm having 26 in this side. I'm having 26 here. Here is going to be 26. So the other side is going to be what? 4 brackets. I have it as, okay, this is going to be 2 times 16 is going to give me 32. 2 times 16 is going to give me 32. 32 plus 12 is going to give me what? 44. So I have here to be 44. So multiply out. 2 times 26 will give me what? If you can multiply some things with your head, it's going to be a bit faster. This is going to be 52. 52 is going to give you what now? 4 times 44. 4 times 44 will give me what? So 176. This is 176 gram. Sorry, 176. Sorry. This is going to be what now? 176 gram of carbon dioxide. So whereby this is for the ethane, this is for ethane. So since we have this gram, so since we've gotten this grammage, or we've gotten all this gram from the equation, what am I going to do is I'm going to include this one. I will now say that my 78 gram will be what? you know, this 78 gram, I got it from the question. It is given, they said 78 gram of ethyne, whereas I got from the equation of the reaction that ethyne is 52 gram. First of all, that's the first you need to get. Then you now start looking for the mass the 78 gram of ethyne will now give, which is what they ask in the question. So what I'm just trying to say is these are the ones I got from the equation, this equation. Then I have to place my 78 gram of ethyne under ethyne. Then we're looking for that of carbon oxide. I'll now cross multiply. So what I'm going to have is x is going to be what now? X is going to be 78 times 176 all divided by what? 52. So 52. I'm writing 56. What's wrong? All divided by what? 52. So this is going to give you what now? Let's look at it. It's going to be 78 times 176 is going to give me 137 divided by 52 divided by 52. The answer is going to give me what now? It's going to give me 264. So I'm having the answer to be what? 264. I'm having it as 264 gram. So here I'm having it as 264 what? Gram of what? Carbon dioxide. So you now see the way I solved it, the process that I used. Okay, so that is it. So for question number 16, what do you have for question number 16? Quick one, because question number 16, what do you have other question number 16? Question number 16 says what? A particle contains 11 protons. Proton has to do with positive charge. So it contains 11 protons. You remember, it simply means that it has 11 positive charge now. Then they say 12 neutrons have no charge. Nothing has nil charge, has no charge. Then 10 electrons means what? A negative charge. But this, if the value of proton and electrons are the same, the elements will be neutral. But if one is greater, the element will either be positive charge or negative charge, depending on the one that is greater. So from the look of this now, which of them is greater? Now the one that is greater is what? Proton is greater. So for that reason, that element is going to be positive charge. And positive charge, element that is positive charge is known as what? We call it what? Metallic ions. We call them the metallic ions. Whereas the ones that, assuming it is negative ones are called the non-metallic what? Ions. So which means that metals group 1, group 2, group 3 will give you what you call metallic ions, whereas non-metals like 5, 6, 7 will give you what you call the non-metallic ions. So what is the answer to this question? The answer is option A. So pick one. Now the next question says the elements with the electronic configuration. Well, if you want to get the element, to know the element, just quickly count out the electrons that is on top of each of them. We have the first one 2, we have the next one 2, we have the third one 3. I will say 2 plus 2 plus 3, and that will give me automatic what? 7. And if you count from your periodic table, hydrogen, helium, lithium, beryllium, but if you keep counting, the element that will give you 7, or the seventh element, or element with atomic number 7 is what? Is nitrogen. So the correct option is what? Nitrogen, as this. So nitrogen is the correct option. So that is it. So now let's look at the next question, quick one. The next question says a difference between chemical and physical change is that in a chemical change, what happened in a chemical change? They say heat is supplied. Well, a new substance is formed, which is the key thing. Let's see if we have other options. Oxygen is consumed, nothing concerns that. A reversible process occurs. Reversible process occurs in terms of equilibrium reaction, if the reaction is in equilibrium. So nothing concerns that now. So the correct option is option B. All right. So the next one that we're going to have is this. Now, please pay attention to this question. Question number 19. Pay attention. Question number 19 says, a decrease in atomic size and an increase in nuclear charge. Decrease in atomic size. Decrease in atomic size. They say the atomic size is decreasing. Decrease in atomic size. So the atomic size is decreasing. So a decrease in atomic size and an increase in nuclear charge. nuclear charge, pay attention to this. Let me tell you what is going to happen. Across a period, that is from one, across that period, let's say period 2. So if you're going from under that same period 2, if you're going from left to right, what will happen? See, if something like that happen, even though the size of the atom is being decreased, what happen now? Automatically, and the nuclear charge is increasing, automatically it simply means that the element is becoming more electropositive. It's going to become more electropositive. So let's look at the options that we have here now. A decrease in there's something like covalence in this one, so option A is wrong. An increase in chemical reactivity, option B is also wrong. An increase in tendency to lose electron, option C is also wrong. A decrease in electropositivity, so which is the correct one. So if you're going across the period, what happens now? Electropositivity decreases. Electropositivity does what now? Decreases. Now let me just quickly give you a rundown what you call periodicity of elements. Let me just quickly run that so that you know the one that is increasing and the one that is decreasing across the period. That's the essence of this class that we're doing, because the essence of this class is this: we do some, and if we have anything that we need to talk about, we'll just quickly talk about it. Now let's look at it now. Let me just give you a quick rundown of that now. For a quick rundown of this now, you need to take note of the following. We have what you call the atomic property. Let's look at, we have what you call the atomic property. Write down this property. We have atomic property. Okay, we have atomic property. Then, okay, let me rule this one first. Then aside that, now we have what you call trend across the period. Trend across the period. Then the next one is going to be trend down the group. Trend down the group. So if you look at this now, what are we going to have now? Let's look at the first one. Let's look at the first atomic property. The first one we are going to have is what we call atomic volume. Atomic volume. Atomic what? Volume. Atomic volume. Across the period, what happens to atomic volume across the period? It does what? It decreases. And if it decreases across the period, please, across the period means from left to right. From left to right. Then down the group means from up to down of a particular group. The group that we have is, we have group 1, we have group 2, we have group 3, we have group 4, and so on. So down the group is going to be what? Increase. So you see that. Then the next one that I'm going to talk about is called atomic radius. Atomic what? Radius. For atomic radius, what happens to atomic radius now? Across the period, what happened again? It decreases. It decreases. Then it also increases down the group. Increases down the group. Increase. The next one is what we call ionic radius. Ionic radius. Ionic radius. Ionic radius. What happens to ionic radius now? Ionic radius does one thing, which is what? Ionic radius does one thing, also decreases. This one is also what? It decreases. It also decreases and also increases down the group. Then aside that, what again am I going to have now? I have ionization energy. From this ionization energy, this is your IEEE. I always use the word IEEE to remember it. So I is your ionization energy. Ionization energy. That's number. Then number 5, I will tell you what is going to happen here. So, but let me write it out first before I explain. Let me roll this one up. Okay, my next E is going to be what? Electron affinity. E, the first E I'm going to have is electron affinity. Anything that belongs to E, electron affinity. Just remember this. Electron affinity. Electron affinity. Then the next one is going to be what? Number 6 is electronegativity. 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 Negativity. Then the last one is going to be what now? Electropositivity. Electropositivity. Positivity. So you see, what do I have here now? I basically call this from number 4, from that number 4, I basically call that number 4 IEE. Let me show you something. The mnemonics I can use is A for atomic volume, another A for atomic radius, then I for ionic radius. Then from number 4, which is ionization A, I will have IEEE. So this 4 has the same property. Why this one has the same property? So what does it mean now? It simply means that coming to this ionization energy, which is the fourth one, it's going to be, here is going to be what? Increase. And here is going to be what? Decrease. For the fifth one, which is electron affinity, it's going to be what? Increase. Here is going to be what? Decrease. I hope you're getting what I'm saying, and I hope you're getting the logic that I'm using here. All this logic are a way of remembering them, so that when you move into the hall and your examiner asks a question, you don't need to stress yourself or guess. You know exactly what you're going to do. So this one is going to be what? Increase. This one is going to be increase, and this one is going to be what? Decrease. Then the last one, which is electronegativity, is increase. The last one, which is electropositivity, is going to be what? Increase across the period. We are going to have increase across the period. So sorry, across the period it's not going to be increase. Sorry, this one is going to be different, which is electropositivity. It's going to be different. It's going to be across the period. What is going to happen to it across the period? It's going to do what now? Decrease. It's going to decrease. So this one is different. Then down the group is going to be what? Increase. That is why we are having, or we're choosing option. That is why we're choosing option D as the correct option. So option D, because decreases. If you are going across the period, what happens? It decreases across the period. Okay, so let's look at question number 20. Question number 20, quick one. Before we just cut this video, we can have another series. Question number 20 says that the idea of planetary electrons, that electrons goes like planets, goes like, reverse like planets, was done by who? Was that of who? Has that an idea of a planetary the idea was that of what you call what Rutherford. It is the idea of who? Rutherford. That is it, not neighbor, not Thomson, rather the idea of what? Rutherford. All right, so in my next series now, I'm going to continue from the next question before to the last one. That is what I'm going to do in my next series now. So but for here, we're going to stop it at this series now. If you are new to this channel, don't forget to subscribe and also click on the notification bell icon. Then also like this video, and also you can also share this video. I will see you in the next series. Thank you.